हाय ध्रुव। आई थिंक बाकी लोगों को ज्वाइन करना है अभी। उनको ये लिंक शेयर किया क्या हमने?
No, not yet. I think Aditya is just sending right now.
ओके कूल। आई हैव मेड यू द को-होस्ट बाय द वे।
Yeah, thanks.
नो वरीज।
I think we can start now. Should we start or wait for a few more people?
I think we should start. So Dhruv, are you taking this or Shaurya is taking it?
I'm taking it. Shaurya got sick, unfortunately, a couple hours
Ah,
ago, so I'm covering.
okay. Um, yeah, sure. Cool.
Okay, let me share my screen. Okay, is my screen visible?
Yep.
Yes.
Okay.
Yes.
So, good evening, everyone. I hope you're all doing well. So, today we're going to be starting with the next part of the bootcamp, which is about RAG, Retrieval Augmented Generation, and the architecture around it. So, this is a really, really interesting kind of attachment to this workshop. So, RAG stands for Retrieval Augmented Generation. So some of you may have read about it. And even if you haven't, what do the words Retrieval Augmented Generation make you think of? So one of you can answer. Okay, so I'm assuming you guys haven't read up on it beforehand. That's fine. So, what retrieval augmented generation means is that you're going to take an external source of data. It could be anything, bunch of Wikipedia articles, PDFs, Excel sheets, or it could be, just random websites. And when a user puts in any kind of LLM query, in addition to just using the large language model to answer it, you're also going to look up into that database of content, grab whatever is relevant, and put that in the prompt before feeding it to the LLM. So, what this does is it allows you to get like a source of data that you can manipulate and that is up to date, using which you can augment the thing that is generated. So, that's why it's called retrieval augmented generation. You're retrieving appropriate information, you're augmenting your prompt with it, and then using that whole thing, you're generating an answer. So yeah, let's start with what is RAG. So basically, uh, there's an example given here for GPT-4, which says what's the year-over-year growth of Netflix right now, as per its latest report. And as you can see, what it says is that it can give you the year-on-year growth of 2020. Note that this may also be a hallucination. This might not be accurate, and you'll actually have to verify this. But given it's not a hallucination, this is still just 2020, 4 years ago. And that's because GPT hasn't been trained on the latest financial reports. It just really has no idea of knowing what's going on currently. So now let's imagine you're kind of building a financial app and a financial LLM app, and you want people to be able to put in questions like this, and you want answers to be completely up to date without having to, incur millions of dollars in cost and retrain the model every month or every time a financial report comes out. So how do you do that? The answer is RAG. So what it does is this is kind of like a little meme showing you. You have a corpus of documents like financial reports. You have a retriever, and every time a query runs, that retriever also runs. It goes to the document corpus. It figures out exactly the chunks from the corpus that you need to answer the question. So that's kind of where the tricky part of RAG comes in, is how do you identify the most important bits that you need to grab from the documents? And then once you retrieve it, then you answer the question with the help of that instead of just using the LLM's inherent knowledge. So here's a video from IBM demonstrating the process. So it's just 6 minutes. So let's watch it. I think this time the audio should be coming through. Let me know if it's not audible.
Large language models, they are everywhere. They get some things amazingly right and other things very interestingly wrong. My name is Marina Danilevsky. I am a senior research scientist here at IBM Research, and I want to tell you about a framework to help large language models be more accurate and more up to date. Retrieval Augmented Generation, or RAG. Let's just talk about the generation part for a minute. So forget the retrieval augmented. So the generation, this refers to large language models, or LLMs, that generate text in response to a user query referred to as a prompt. these models can have some undesirable behavior. I want to tell you an anecdote to illustrate this. So my kids, they recently asked me this question. In our solar system, what planet has the most moons? And my response was, oh, that's really great that you're asking me this question. I loved space when I was your age. Of course, that was like 30 years ago, but I know this. I read an article, and the article said that it was Jupiter and 88 moons. So that's the answer. Now, actually, there's a couple of things wrong with my answer. First of all, I have no source to support what I'm saying. So even though I confidently said, I read an article, I know the answer, I'm not sourcing it. I'm giving the answer off the top of my head. And also, I actually haven't kept up with this for a while, and my answer is out of date. So we have two problems here. One is no source, and the second problem is that I am out of date. And these, in fact, are two behaviors that are often observed as problematic when interacting with large language models. They are LLM challenges. Now, what would have happened if I'd taken a beat and first gone and looked up the answer on a reputable source, like NASA? Well, then I would have been able to say, okay, so the answer is Saturn with 146 moons. And in fact, this keeps changing because scientists keep on discovering more and more moons. So I have now grounded my answer in something more believable. I have not hallucinated or made up an answer. Oh, and by the way, I didn't leak personal information about how long ago it's been since I was obsessed with space. All right, so what does this have to do with large language models? Well, how would a large language model have answered this question? So let's say that I have a user asking this question about moons. A large language model would confidently say, okay, I have been trained, and from what I know in my parameters during my training, the answer is Jupiter. The answer is wrong, but, we don't know. The large language model is very confident in what it answered. Now, what happens when you add this retrieval augmented part here? What does that mean? That means that now, instead of just relying on what the LLM knows, we are adding a content store. This could be open, like the internet. This could be closed, like some collection of documents, collection of policies, whatever. The point, though, now is that the LLM first goes and talks to the content store and says, hey, can you retrieve from me information that is relevant to what the user's query was? And now, with this retriever augmented answer, it's not Jupiter anymore. We know that it is Saturn. What does this look like? Well, first, user prompts the LLM with their question. They say, this is what my question was. And originally, if we're just talking to a generative model, the generative model says, oh, okay, I know the response. Here it is. Here's my response. But now in the RAG framework, the generative model actually has an instruction that says, no. First, go and retrieve relevant content. Combine that with the user's question, and only then generate the answer. So the prompt now has three parts. The instruction to pay attention to the retrieved content, together with the user's question, now give a response, and in fact, now you can give evidence for why your response was what it was. So now hopefully you can see, how does RAG help the two LLM challenges that I had mentioned before? So first of all, I'll start with the out-of-date part. Now, instead of having to retrain your model if new information comes up, like, hey, we found some more moons, now it's a Jupiter again, maybe it'll be Saturn again in the future, all you have to do is you augment your data store with new information, updated information. So now the next time that a user comes and asks the question, we're ready. We just go ahead and retrieve the most up-to-date information. The second problem, source. Well, the large language model is now being instructed to pay attention to primary source data before giving its response, and in fact now being able to give evidence. This makes it less likely to hallucinate or to leak data because it is less likely to rely only on information that it learned during training. It also allows us to get the model to have a behavior that can be very positive, which is knowing when to say, I don't know. If the user's question cannot be reliably answered based on your data store, the model should say, I don't know, instead of making up something that is believable and may mislead the user. This can have a negative effect as well, though, because if the retriever is not sufficiently good to give the large language model the best, most highest quality grounding information, then maybe the user's query that is answerable doesn't get an answer. So this is actually why lots of folks, including many of us here at IBM, are working the problem on both sides. We are both working to improve the retriever, to give the large language model the best quality data on which to ground its response, and also the generative part so that the LLM can give the richest, best response finally to the user when it generates the answer. Thank you for.
Okay, so I hope you guys watched that video and the audio was working this time. So essentially, what she was saying is that it's just a brief recap of what I've already said, and that is that RAG basically allows you to use an up-to-date data store in order to, uh, get relevant data in order to answer a query. And this is important for two reasons. First of all, it'll let you update the data that the model works with in real time without having to retrain it. And the second thing is, once the LLM gives an answer, it can say, hey, this PDF, this exact article from NASA is where I got the answer from. So you can, click and really easily check. It can cite to source where it got the answer from. Whereas with, a normal base model LLM, you don't have that luxury. You can't peek into the weights and see exactly where is this answer coming from. So those are like the two very important things that RAG allows us to do. So here's another video. I'm not going to show this because it's 18 minutes long and it's basically about RAG architecture, which we'll be covering anyway in a second. But basically, it's a video that is a primer on RAG. And it also talks about many of the same things, which is the motivation behind RAG, why to do it, what it helps you with. And it also tells you, how do you implement RAG? What is the actual architecture? So uh, let's go into that part. So basically, there's an image here. Yeah, okay. So there's basically a couple of layers to a RAG application. The first is the user interface layer, which is fairly standard. It's where you put in your query, it's where you get out an answer. That's every chat app has one. Then there's a storage layer, and in the storage layer, you essentially need a vector database in order to store every single, kind of data point that you have in your data store. So the data store that the lady was talking about there is essentially just a vector database. There's a lot of companies which make these: Pinecone, VV8, ChromaDB. There's also Milvus, which is a very big one. Or you can use an in-memory managed vector index. So you don't have to manage a database. And that is actually what Pathway does, who are the people who are conducting this workshop. They're in the business of in-memory managed vector indexing. Then there's the service layer, also known as the chain layer or the pipeline layer. So what this does is, this is the part of your program that's responsible when a query comes in. So when a query comes in, this layer executes, it retrieves whatever is relevant from the data store, it passes it through the LLM, it generates the answer, it gives you back the answer to the UI component. So that's the basic RAG architecture. And here's a diagram of the same. So let me walk you through it. So over on the left, you have source data. So, it's a, maybe it's a folder of text files, a folder of PDFs, a bunch of cloud documents, uh, Kafka topics. If some of you are into stream processing, you would have heard about Apache Kafka. So, you can have data coming in as a stream from Apache Kafka and use it in an LLM application, or it could be a SQL database. There's really no end to it. You can use any kind of unstructured data in your application. You run it through an embedding model. So those of you who attended the word vectors workshop, you would remember that you can take any kind of text data or image data or video data and convert it down into a vector. So that's what an embedding model does. It takes the text of the PDF you've taken, for example, and converts it down into a vector. They've used the OpenAI embedding model here, but there are many open source ones that you can use as well. So yeah, you embed the model. Right. And now I want you guys to put your focus towards the bottom there. So the bottom says, here's an input prompt. Uh, explain how our latest product release, this is the version, will help the customers. So now you have an input prompt. You take the prompt and you convert that also into a vector. So you use the same exact embedding model, that's important, and you convert the input user prompt into a vector as well. And then what your retriever does is it goes to the vector store. It sees the vectors of every single chunk of data that you have, and it compares it with the vector that you have. Now how can you compare vectors? Well, in JE physics class you might have seen, you can just use cosine similarity. So if you have two vectors, take the you can take the dot product of them and you'll get the cosine of the angle. And that's actually how you can measure, one way of how you can measure vector similarity. So what you want to do is find the chunks that are closest using that vector math. That's what the retrieval mechanism in the middle there does. Once you found the chunks that are the closest, maybe you found 4 or 5, you take that, you put it in the prompt, you give it to OpenAI or whatever normal LLM model you want, and the prompt can have all kinds of different parameters. It can have all kinds of different guardrail prompts that you want. Like for example, as she said, uh, you can have a guardrail prompt that says if these sources don't have the answer, then just say I don't know. Don't try to make up an answer. So that will really help lower the amount of hallucination that a model does, because it's not trying to force an answer. If it doesn't have one, it'll just say I don't know. And then you send this answer to the chat interface. User is happy, he gets the latest data, everything is fine. So that's an overview of how RAG works. Uh, so yeah, here's a basic description of each component. Data sources. So your starting point can be cloud storage. It can even be a Git repo with code in it. Uh, it could be a database like SQL. Uh, then you use vector indexing. So you use an embedding model to convert your data into vectors. Query transformation. So you take the user's query, you also convert it into a vector. Contextual retriever. So you use an algorithm in order to find out which are the closest vectors to this. Text generation. So then you take the prompt and you generate text to the LLM as usual, and then you put it out onto the user interface. So to those of you who are new to RAG, this might be a little bit, a lot right now. So do any of you have any questions, any doubts, any kind of anything at all that you want to ask? Then you can ask right now.
Can you later at the end explain about RAG versus fine tuning a bit?
Yeah, so that's the next slide.
Fine tuning.
So yeah, that's exactly what we're going to be explaining now.
Okay.
So they've compared RAG to fine tuning over here, and they've compared RAG to prompt engineering, two different comparisons. So the first comparison here is fine tuning versus RAG. So the motivation here is, hey, I have a bunch of data. The model's outdated. So why don't you just take this new data and fine tune the model with this data? And what's wrong with that? And the answer is nothing really is wrong with that. Your LLM can also give answers using that. That's uh, a bunch of companies do actually are all in on fine tuning, and they fine tune for new data. But here's the issue with that. So when you fine tune a model, you're changing weights in a very fundamental way, which means that all you what you have to do is train the data. You have to prep the data in a very specific way. You have to ensure that the data does not have a bias towards anything, because then uh, if you have training data that is way too biased towards one side, for example, which can very easily happen if you're scraping the data from the internet, then the weights of the model shift towards that side, and the conversational aspect of it will change. And there are people with PhDs whose entire job it is to prevent this, because LLM fine tuning is itself a bit of a very difficult art. So you know prepping data for an LLM is difficult. It's a difficult task. That's the first hassle that you have with fine tuning. Second is cost efficiency. So the kind of analysis given here is that if you're using RAG, then you don't need to fine tune at all. And because of that, using a RAG is roughly 80 times less expensive than fine tuning, which actually seems a bit low to me. Fine tuning is extremely expensive because, again, you're changing weights, you're training a model. It's not a small task at all. So, yeah. And the worst part about it is data freshness. So let's say, new financial reports come out. It's 2025. There are 4 more financial reports from Netflix. You need to incorporate these. Well, now you have to sit and A, do the data processing again, and B, do the fine tuning again. There's no getting around it. And you will have to incur that entire cost again. There's also a problem with, if you feed a ton of data into it, LLM can forget, because if the LLM doesn't have a huge amount of parameters, it might start forgetting older data as you're training new data. All of these are not problems with RAG is just a database. It can't forget data. Given your retriever is good enough, you can always find old data if you want, and you don't have to train the model upfront. It's very little cost upfront. So that is the main advantage that you have with RAG over fine tuning. The second thing is prompt engineering. So RAG, I would say, is the most applications of RAG out there are a kind of, you could call it automated prompt engineering, although that is extremely, extremely inaccurate. But the final step of it can be called automated prompt engineering. Here they've compared manual prompt engineering to RAG. So first is data privacy. When you're building out a prompt to get an answer, you'll have to copy paste data from outside. A, you have to do it manually, which is a drag, and B, if it's sensitive information, if it's an organization giving this chatbot to its users, you don't want to give the raw data to the users because that's a data privacy risk. uh, Inefficient retrieval as well. So if you're not using a vector database or in-memory vector store, and you're not vectorizing the index, then there's really no good way to efficiently retrieve chunks. It's very difficult, because you kind of have to already know what you're looking for before you can find a chunk. And in that case, LLM ko kyun puchna hai? So retrieval is inefficient in prompt engineering, and token limit constraints. So you can't just take a bunch of data and give a bunch of data to the LLM, because you'll exceed the token limit. You need to actually find a few chunks that are relevant instead of just stuffing a bunch of data into it. So RAG is a good alternative to both of these because of these reasons. It solves all of this. So yeah, versatility and efficiency in RAG. Uh, this is getting a bit wordy and explanatory, so forgive me. But uh, right after this, we'll have a fun demo, which will be better. So, are there any doubts in the previous section that any of you had? Okay. So I'm assuming no doubts. That's great. Yeah. So basically, RAG is also very, very versatile, as you'll see here. What data types can RAG handle? So there's really no limit to the kind of data types that RAG can handle. In fact, I wanted to show you something over here. So just 1 second. Yeah. So Llama Index. Llama Index is essentially one of the libraries that you can use for building RAG. It's not the only one, and it's not only used for RAG, it's used for a bunch of LLM stuff. But basically, what you can see is Llama Index has a community of open source contributors. So there's an open source library, and you can go into, for example, data loaders, and you can see these are all just third-party data loaders that people have made. So you can, there's one which reads a news article. So you feed it a URL, it reads a news article, it puts the content into a vector store. There's a CSV reader, so you can read Excel files actually. There's an image reader, so you can convert images into vectors. IPyNB reader. So if you have code in Jupyter Notebook, you can use it to, retrieve in your LLM app, so it can actually read your code and give suggestions, for example. And docx reader, so you can do Word documents as well. And I can keep scrolling, and there's hundreds, literally hundreds. There's really no limit to the kind of data you can feed to an LLM, because you can always interconvert. So yeah, RAG can handle everything, almost everything. Are vector database is necessary for RAG? Short answer is no. So essentially, a vector database is like a database, SQL, MongoDB, whichever database you want, but it specializes in using vectors. So what it specializes in is storing each chunk along with a vector. As I just said, you embed each chunk with an embedding model. So that's the vector. And what they really specialize in is when a user query comes in, fetching the most relevant 4 or 5 chunks, and that is what they're built for. That's what they're very fast at. So as I said, there's a bunch of vector databases: Pinecone, VV8, Milvus, ChromaDB is a very big one. So yeah, vector databases, most RAG applications use them, but there's also a way to do it without. So as I also said, Pathway can generate its own vector index and it can keep it in memory. So it doesn't really need a database. It can handle the vectorization comparison in memory while the program is running itself. So yeah, basically you don't need a vector database. Most people do use vector databases, which is why there are so many of them. Is a separate real-time processing network needed. So for example, if you have a stream of data coming in, let's say it's a news website which is consistently putting out news articles, do you need a real-time processing network? The answer is no, you don't need to build your own. Uh, Again, Pathway, the people behind this workshop, actually are in the business of building a real-time data processing pipeline to do that. So, like Pathway, there are bunch of data processing pipelines out there that you can just use in Python off the shelf. We'll be using one today. It's not real time, but I'll be in the demo showing you one today. Is the ChatGPT plugin for Bing search an example of RAG? So ChatGPT has a bunch of plugins. One of them allows you to do Bing search from within ChatGPT. So it can retrieve a bunch of related web pages. Uh, so these can be considered LLM apps. What these do is, when you ask a question like who scored the most goals, it can go to the internet, it can retrieve the most. Instead of a vector retriever, it's using Bing search, regular search engines, but that's also a form of retrieval. So it's retrieving websites which would give you this answer. It'll return the content of that web page, and then it'll use GPT to help answer this. So yeah, you can consider this an LLM, a RAG application, because under the hood, that is exactly what it is doing. Before the demo, very last thing, why would you use RAG? You're working at a company, you want to build an LLM app, why RAG, right? So the first thing is real-time learning for trusted and relevant information. So let's say your company has a HR policies which are in a bunch of PDFs. You can use those as a ground truth source of information for your model very easily. Plus you can also update it in real time. When you update the documents, the answers from the LLM will get updated automatically, right? Data governance and security. So because you're retrieving from the data store and the data store is owned by you, you don't have to send your documents to OpenAI, for example, when you're fine tuning. You don't have to send data to OpenAI. And if you use an open source model, you don't actually have to send anything to OpenAI at all. So data security is preserved when it comes to RAG, which is why lots of companies use RAG. And minimize hallucination. So you obviously want the most accurate answer possible. And data stores allow you to have A, less hallucination, and B, when the model is about to hallucinate, you can just prompt it to say, I don't know, instead of trying to force an answer. You get clarity on data sources. What this means is, you are writing the code. You control the pipeline when the data is getting sourced. So what you can do is, along with the answer, also give a couple of links which say, hey, this is the document where the answer comes from. So you can literally cite exactly to source where your answer is coming from. That's very powerful. It's compliance ready, again, because you don't have to send your private documents anywhere outside if you don't want to. It's compliant with every single data privacy law that any country would have. Streamlined customization. So there's a bunch of RAG libraries, and RAG can be customized. Like you can, I'll show you in the demo how you can store metadata with your documents, and then you can filter on them, for example. So that I'll actually want to demonstrate instead of actually saying. So they've shown a real world use case. So for real time context sensitive customer assistance. So because it's very private, if you're using an open source model, you could develop an application for a bank which actually has your account details. So you can say, given my account, exactly, what my credit rating is, what my account info is, what type of account it is. I want to buy this. How do I do it? Do I get a loan from this provider? Am I able to get a loan for this? you can have a app that is extremely personalized, or you can do content curation. So you can have an LLM suggest to you 10 articles to learn about AI, which are very, very recent, and it can retrieve them and do that for you. So, it's extremely powerful what RAG can do. So that's the theory. So before I move on to actually building a RAG application with you guys, do you have any questions about the theory itself? How to do RAG, whatever. Okay, so again, no doubts. Looks like that's great. So yeah, I'm going to open a Google Colab notebook over here. I'd suggest, even if you're familiar with Google Colab, not to code along, because this isn't exactly a code along. I'll be copy pasting code, so it'll be hard to keep up. So I'd just recommend, look at the screen, look at the code instead of trying to code along right now. So yeah, at the very start, I'm going to use a GPU runtime to make it much faster to build a vector database, because it can take some time. I'll connect it. I'll be uh, I'll be sharing this Google Colab file with you all right at the end after the session, so you guys can play around with it yourself also. So yeah, this is code I'm copying over from another tab, which I've tested beforehand. So first of all, we're just going to install all the Python libraries you'll need. So the first one is LangChain. LangChain is an alternative to Llama Index, which I just showed you. So that is also a library that you can use, not just for RAG, but for all sorts of LLM applications. Uh, have you guys heard of Devin, the AI kind of AI software
Yeah.
engineer?
Code
Yeah.
assistant.
So on GitHub, there's actually an open version of Devin that a bunch of people have made, and it uses LangChain under
Devika.
the hood. Yeah. So basically, LangChain allows you to do that. It allows you to develop agentic LLMs, which can, perform actions, call external tools, and also, as RAG, depend on a data store from outside and get data from outside. LangChain can do all of that. So we're basically installing a bunch of LangChain modules. We're installing ChromaDB, which is a vector database. So one of many, you can use a bunch of them. Another popular vector database is FAISS, FAISS. So yeah, these are just ChromaDB is the one I'm going for because it's very, very easy. And BS4, that is Beautiful Soup 4, because Beautiful Soup 4 is basically a library to take a web page and extract content from it. So we're going to
Web
be,
scraping.
yeah. So basically it's for web scraping, because we're going to be using websites as the input data for a RAG over here. So yeah, this will just take a couple seconds to install. Until then, this next bit of code will just let me enter my OpenAI key securely. Yeah, so I'll just run this and I'll open a new tab and get my OpenAI key from somewhere. So basically, you do need an OpenAI key to run this, because end May we're going to be using an LLM and I want to use 3.5. But what would be actually a very fun challenge for you guys is try and basically adapt this exact same code to run on an open source model from Hugging Face. It shouldn't take too long, because LangChain has excellent documentation and it has modules already built in to run open source models. So all you have to do is swap it out. I'll
Um,
show it to you a bit more in detail a bit later on. And so this is the next block. This is where the RAG starts. So we'll import Beautiful Soup. We'll import a document loader. So LangChain also has community document loaders, just like Llama Hub, which I showed you. One of them is web-based loader, which lets you grab a web page, take its content, and have it be as a document in your database, right? So here's a web path that I have. I'll open it. It's a blog about LLMs. So yeah, this is the web page that we're going to be using. What this web page describes is LLM powered agents. And this cites basically research papers from 2022, 2023, 2024. So the LLM has no way of knowing such cutting edge kind of techniques for LLMs, but this blog post knows it. So let's leverage that information. So what we're doing is we're creating a loader. We're putting in the web path so it knows which path to go. We're telling it use Beautiful Soup 4 to get the title, the header, and the content from the web page. And then we're basically putting it into a variable called docs. So let's run it. Invalid URL. I've given a invalid URL somewhere, I think. Does this URL look wrong to anybody? Okay, yeah. So the kind of problem that was here is that uh, this is supposed to be a list, but I didn't put a comma here, so it thought this string was the list, and it was only taking the first character over here. So it was saying H is not a URL. So yeah, very, very silly mistake happens in Python. Yeah, I fixed the code now. It has run. So now let's see docs में क्या है. It'll just show a bunch of text probably. Yeah. So as you can see, it's a list, right? It's a Python list. So let's take the first element of it. And as you can see, it's a document object. So LangChain provides these document objects to you, and this is the form in which every single thing is put into the vector database. And it has a variable called page content. So let's grab the page content and let's print it out. Let's see what it has done. Right. So as you can see, LangChain has gone and grabbed this entire article, and it's gotten the page content for us over here, thanks to Beautiful Soup. So yeah, it's gotten every single text on the page. It hasn't gotten the images. This is a very, very basic RAG I'm building over here. You can do a lot more than this when it comes to your data pipelines. But yeah, so we have a document. That's perfect. So now what we want to do is split this, because as I said, the context length of the context length of an LLM is short. If we put this entire article in, it's going to say context length exceeded. We can't do anything with it. And B, we're basically trying to look for a needle in a haystack, right? When we put in a query, we want uh, the exact paragraph that has the words in that query to get pulled out. We don't want the entire thing to get pulled out. That's not very useful. So what we do is we split this into chunks, right? And LangChain again offers inbuilt module to just do that. All you do is you create a text splitter. You tell it how long you want your chunks to be. So here I've said make me chunks of 1,000 tokens, approximately 750 words, and I'll just split it. So yeah, so now I basically have a split, which is just a list of different documents. So it's still document objects only. Let me scroll down. It's still a list of document objects, but if I take the length of this, it's going to be 66. So I've split this article into 66 chunks. And now I'm going to insert these chunks into a vector database. So I'm importing from Llama index, right? So you remember in that block diagram, they used OpenAI embeddings. I don't want to use OpenAI embeddings because it can get expensive. So I want to use open source embeddings over here. And for open source embeddings, you just say what model you want, and it'll basically just grab that model from Hugging Face and use it as is. That is how easy LangChain is. So basically what we're doing here is we're creating a vector embedding model, pulling it from Hugging Face. Then we're creating a vector store, which is ChromaDB. And we're embedding all the documents that we had before, those 66 documents. And we're using the embedding model that we just created, this HF, right? So this is basically the part where you're building your data store. This vector store variable over here is what we will use to refer to the vector store from now on. So let's run this also. It should not take too long to run. I think like 10 seconds max. It's going to pull the model from Hugging Face first. So you should see a couple of download bars over here. Yeah, there it is. And once it pulls the model from Hugging Face, it's going to run the, so this is the embedding model, not the LLM model. Embedding models are on their own a bunch of, topic of research. So yeah, you could use OpenAI embeddings here as well. And you can see how easy it is in LangChain. You just swap out OpenAI embeddings for Hugging Face embeddings here. You give it the parameters it wants. You pass it in over here, and it just handles the rest. So that's why I want you guys to try out switching out the LLM from OpenAI to Hugging Face, because I want you guys to see how easy it is. So yeah. And now what you're going to do is you're going to create a retriever. Right. So now you've built your data store. You have a store of 66 documents. You also have vectors alongside them which describe, what is this document about. Now you'll create a retriever variable, which, you basically use to search across this vector store. Search type similarity. So this is cosine similarity that I was talking about before. You could change it over here. And k equal to 4, which means every time I search, it's going to give me up to 4 relevant results. I could increase this if I want, but 4 is fine. So do you guys have any doubts up to this point? The kind of...
Can one use similar models to OpenAI like Gemini 1.2 for this?
Absolutely. Absolutely. So as I showed you that open source hub, people just make integrations. So you can see it's completely modular over here, right? LangChain community.embeddings, import this embeddings. There's like 6 or 7 different embedding providers you could use here. You could use an API also for embeddings. There's Chroma here. They have literally, I think, 50 or 60 vector stores implemented. All you have to do is swap it out over here. And same with the LLM. So with the LLM, they have OpenAI, they have Hugging Face, they have Gemini, they have Microsoft, everything. So, all you have to do is swap out that part of the code, and you can use, any provider you want. So now let's test out this retriever, right? For that, you use retriever.invoke and you put in a query. So one of the things that she talks about, Lillian Weng, this is Lillian Weng's blog. So one of the things that Lillian talks about is task decomposition. So task decomposition is basically, if you give an LLM a very complex task, uh, actually the first step that the LLM should do is decompose it into 3 or 4 tasks and then try to solve them. So how do you force an LLM to do that? That is task decomposition. So uh, we want to basically retrieve kind of this part and the paragraphs around this part. So, let's try that. Uh, let's try retrieving them and see what we get. So it ran. We got some retrieved docs. Let's look into these retrieved docs and see. So it should be a list of 4 documents. As I said, we're retrieving 4. So yeah, exactly. So the first thing it's citing is this tree of thought point, which is over here. That's good. It's also giving overview of an LLM powered autonomous agent system, component 1 planning. So it's giving us the chunk starting from here. It's giving us this, and it's giving us this. So, and it's giving us 2 others also. So it's working. The retriever is working. It's actually retrieving the chunks you want to. That's really cool. So yeah, we have the retrieve docs. What do you guys think this case should be? Any guesses?
Like similarity, like clustering the words similar to it.
So I mean, yeah. So I mentioned we're using GPT 3.5, right? The context length is 4096, and we also know each of our chunks is 1,000 tokens, right? 4 is actually getting a bit close to that limit because prompting karke it might go over 4096. So what I really want is a k of 3, right? So that gives me a bit of breathing room for my prompt. So I'll keep k as 3. And you can see here, it's now only giving me 3 documents. So our retriever works. Let's actually use it for an LLM. So this is the fun part. We're going to import this chat OpenAI. Because I put in my OpenAI key earlier, it should just do this. And as you can see, this is all you have to do to, put OpenAI into your project. All you have to do is instead of chat OpenAI, import something else over here. give it the variables it wants, and you can use any other LLM, literally any other LLM. So that's cool. You can also get prompts other people have made. So there is a generic RAG prompt that you get with LangChain. I'm just going to pull it. Uh, I want you guys to basically, play around with your own prompts, but this is just a pre-made one. And this is how the prompt works in LangChain. So you give it any string in the context, you give it any string in the question, and it's going to give you this message as an output. You are an assistant for question answering task. Use the following pieces of context to answer the question. And if you don't know the answer, just say you don't know. Use 3 sentences maximum and keep the answer concise. Question, filler question, which I've given over here. Context, filler context, which I've given over here. Answer, and then it leaves the LLM to generate the answer. So this is a good prompt. It says to keep the sentence, keep it to 3 sentences maximum, which I think is fine. But if you want a longer answer, you need to modify this, make your own prompt. So yeah, so now I'm just going to basically finish up the RAG app. So I'm going to take an input, which will be my query, right? Then I'm going to retrieve the docs. I'm going to retrieve docs from the data store. I'm going to put it into context as a bunch of strings. Then I'm going to put it into the prompt, which I just showed you, right? And then I'm going to, in this last block over here, I'm going to call the LLM and give it that prompt, and let's see what the answer is. So yeah, and over here, what I'm doing is I'm just putting in the query without any context. So let's see what happens when that happens, and let's do something. Let's do something interesting also. So let's also run the RAG, but let's not give it any pieces of context. So it should say, I don't know. I don't know what the answer is going to be to this. So let's try it out. But yeah, so let's do this. What are the approaches to task decomposition? I'll ask this question only, right? So press enter. It'll retrieve the documents. I'll stop this right now. So it'll retrieve documents. It'll put it in the retrieve docs variable. I'll join all the content together. I'll put it in the prompt. So that's what this block does. And then I'm going to send this off to 3.5, and it's going to generate an answer. So yeah, this is the answer it's given me. The approaches to task decomposition involve using LLM with simple prompting, task-specific instructions, and human inputs. Task decomposition involves breaking down a problem into smaller steps to make it manageable and improve model performance. Reflection is a framework that equips agents with dynamic memory and self-reflection capabilities. So it's giving perfect answer right now, according to the retrieve chunks, which is perfect. Now, what answer would 3.5 give uh, if I didn't use RAG at all? So the answer is giving here. Note it's a bit longer because वहाँ पे prompt में we had put keep your answer concise to a line, but over here we haven't given such a thing. We've just given what are the approaches to task decomposition. But as you can see, it's giving us the wrong answer actually. I think this is a method of task decomposition in object-oriented programming, if I'm not wrong. So it's not actually giving me the correct task decomposition that I want. So if I was building a chatbot for, uh, teaching me about LLMs, and I feed it blog posts about LLMs like this, you can imagine how powerful this is because it'll give you cited, very, very recent research. And the best part is, as a programmer, this context variable, this retrieve docs variable, you actually have, I'm going to print it out over here just to show you. You actually have the document. And note, along with the content, you also have some metadata which says source and it has the URL. So what you can actually do is create an app which gives you little links on the bottom that says this is the blog post where you can read more about it. So you can cite your source. That's really cool. And it even gives the start index. So you can literally go to the exact line in the exact blog where that answer came from. That's really, really powerful. So yeah, this is the entire RAG pipeline. By doing it, I hope you've understood it. You take some content, you divide it into chunks, you put it into a vector DB, uh, you take a retriever out of that vector DB, then you take the user's query. उस query के हिसाब से retrieve as many chunks as you want out of the database. Append those chunks into your query, which you are sending to OpenAI. Then you use an LLM to print the answer. That's the workflow with RAG. So yeah, I'll be sharing this sheet with you guys. LangChain is pretty cool. I encourage you guys to look into Llama Index also. The documentation for both is excellent. And really, I want you guys to look into Pathway because they're doing some really cool stuff. So Pathway is miles faster than both LangChain and Llama Index. It's built for really heavy duty applications, and it can do what both of these can't, which is stream processing. So you can take a live stream of data and use it to answer queries. It's written in Rust and it's really fast. So yeah, there's a bunch of RAG frameworks which you can use. LangChain is just very easy. You can do it in a few lines. This is why I wanted to show it to you. So yeah, that ends the workshop. There's just a bunch of couple of bonus modules over here that I suggest you read. The first is about how do you actually get the relevant closed chunks. So we used cosine similarity, but there's actually a couple of algorithms to do it, right? Uh, then there is basically how do you do it fast. So when you're building a vector index, what might come to your mind is, hey, I have a billion documents over here with a billion vectors, and I have one vector I want to compare. So I'll just go through each of the billion vectors and compare and see value kitna hai, similarity value 0 se 1, and I'll take the top four. But as you can imagine, doing that for a billion vectors will take literally like a few minutes, and nobody will use your app agar tum query dal rahe ho and it's taking 3 minutes to start getting an answer. So here are a few very interesting algorithms in order to optimize this. How do you search through a billion vectors really quickly? They've used LSH, which is local sensitive hashing. There's also this interesting algorithm called HNSW, hierarchical navigable small worlds, which kind of uses trees to divide up the space into halves every time you search. So within 6 or 7 hops, you can get the exact 4 or 5 close vectors. So, there are a bunch of really interesting data structures and algorithms work and really interesting research papers that people have come up with on how do you solve this problem of doing it fast when you have a bunch of documents. That's what the bonus modules are about. And here's finally a 10-question graded quiz, which brings us to the end of this module. If you guys have any doubts, you can say right now. Otherwise, yeah, I hope this session was really fun. And this is really the meat and potatoes of what this 3-week bootcamp wanted to get into is, how do you build a RAG? What is a RAG? How do you build it? So yeah, I hope you guys enjoyed. Do you guys have any doubts just before we end off?
So like we used the block and used that and converted that into vector embeddings and then used dual languages. So can we use images or like PDFs also?
Of course. So what you can do is there's image to vector models out there, right?
Yeah.
What you basically want is essentially you can either train your own model, which is expensive, or you can use a multimodal model on Hugging Face, जो कि takes text and takes images also and converts them to vectors. What you have to be mindful of is two things. First is, अगर तुम separate models use कर रहे हो images को embed करने database में, then make sure कि the dimension of vector is the same. So for example, अगर text के लिए you're using OpenAI's embeddings model, that's 1536 dimensions. Make sure the image wala model you're using is also the same. Otherwise, if you have, for example, in physics, you might have used, agar 3D vector or 2D vector, you can't take the dot product. You can't compare them. Same will happen here. So make sure the dimensions are same and make sure you're getting an accurate answer. If you're asking a related question, then wohi image aa raha and not some other. So yeah, absolutely. Like all you have to do is convert it to a vector and retrieve, the correct image at the correct time. As long as you can do that, sky's the limit with what kind of thing you can put into a vector DB. There's really no limit at all. So yeah, any other doubts from you guys?
Just want to add a small thing.
Yeah.
Um,
I'll stop screen sharing actually.
yeah.
One moment.
First of a very great presentation. Slightly strange coming from me being on the same side of yours, since we, but yeah, still a very good presentation. And a session. A small addition. So basically, around something like, as you mentioned, as Dhruv mentioned, there's this concept of retrievers and loaders, PDS and all around these frameworks like LangChain, Lamatics and all. So if you want to use, like, Pathway has its own, like if you go to LLM app, just search for LLM app space, uh, the search for LLM app on LLM app space GitHub. I think the repository by Pathway should show up, or else you can type Pathway also and see if it comes up. You can build an end-to-end RAG using Pathway. However, if you want to use it with something like Llama Index or LangChain, so you can use Pathway as a retriever also. There, the main context is about retrieving more efficiently and also indexing data real time. For example, as you have, for example, take the use case of a customer support executive, or the example that is put there in the bootcamp is, let's say you're a legal professional and you, you are Netflix, okay, and as Netflix, your team is working with so many OTT creators. With every single creator you have a contract being signed, and this applies to every single edtech, every single OTT platform, every single music company. Just imagine the use cases, right? Now every contract will have a different nature. You want all of that to be maintained in a single place. So if something is breaking, you might want to have an alert, and you might also want to be able to give some contextual answers with the help of RAG. So that involves, kind of indexing a massive amount of documents coming from various offices around the world. So that is one use case where real time becomes useful, or the financial use cases. For example, numbers are changing continuously. You want something, or the product release bit, right? Recently in India, even I think this I shared at Trist also. So, for example, Mintra had launched a Mintra chat. I'm not sure why they shelved it, but they have this particular chat option where you can use it. Now, in that case, we're talking about indexing. I do not know if they were creating a real-time vector index, but in principle, if you're doing it purely via vector search, it will involve creating a real-time vector index. So there also you can use these kinds of things. Also, just to add one more small thing, think yeah, one more other use case that typically sits in the enterprise settings. A couple of them is also around understanding the PII. PII is basically personally identifiable information or hierarchical structures. For example, imagine I am, working at Pathway and I want to know how much is the CT of Pathway earning. And I have this, my company has built this RAG tool for HR support. And I'm just asking, hey, tell me how much a salary of Yan Choraski has increased over the past 1 year. Now, technically, me being someone, let's assume I'm lower than him in designation, I should not be able to get the answer to it, right? But the RAG will end up doing it, or a simple fine-tuned model will end up doing it. That's when you can also put these kind of rules in place, which will say that, okay, given this particular question, nature of question, and the designation of the person, this question should or should not be answered. So those are typical use cases why, I mean, if you look at it, essentially, it is not a very not ultra complex thing to be solved, but for companies, this becomes really critical, whereas that is where you as problem solvers become very relevant in solving those things. That's, yeah, that I would shelf. I mean, yeah, that's it. Nothing else I would want to mention for now. Dhruv, do you have anything else to mention, or is there any queries that is there from the Janta that we can answer? The hands-on module is yet to be released. We'll be releasing it very soon. We wanted to cover this particular session first, and then the hands-on module will be released. Yeah.
I guess nobody has any questions. So do check out Pathway, guys. I thought it was really, really cool. They're doing good stuff, and you can check out their repo on GitHub. Uh, it's a very, very cool framework to play around with if you guys want to build RAG for sure. Uh, and as Mudit said, that's actually a very, very compelling point in RAG's case is, you want a chatbot where different users have access to different data. Like you don't want the access to salary information of seniors, but of juniors might be useful. So you can actually do that because it's like a database query. You can gate certain data behind certain people, which you can do with RAG. So yeah, sky's the limit, and that's why people use RAG.
Yeah,
That's
and
it.
one small additional thing I would say is, so Pathway does it. Also, there's this company called as Glean that actively hires from IT Delhi as well. I think. I mean, my friends from Bombay are hired there, so I know that for sure. But so all of these companies, when they apply, when they tend to, when they're hired by companies paying crores of rupees, trying to solve some problems, sometimes they may also end up using a combination of uh, not just vector search, but a combination of vector search plus something like semantic search, similar to what Google does, and plus something like knowledge graphs. Okay, that is all with the singular goal of making retrieval more and more efficient. As you will start building your RAG projects, you'll see sometimes it will end up giving a very relatively underwhelming response. And that's because RAG as a field is pretty new, but it is extremely popular. Many companies, when they're talking about implementing RAG, they are about implementing Gen AI, they end up talking about RAG quite often. So it's relevant that way, but it's a field where you can always think how you can make this retrieval more and more efficient or more trustworthy. That's where things like Dhruv gave a very interesting example of verifying where this is coming from via the metadata. That is extremely valuable piece of information as well to be given. Uh, okay, cool. And yeah, many thanks, Dhruv, for the kind mention of Pathway. Really appreciate it. With that, we'll wrap this session. If you have any questions, you can put them in the Discord or on WhatsApp. Okay. Thank you, everyone.
Thank you, everybody.